Okay, so looking at question 1, when you see a chain of carbons across the middle of the polymer like that, you know that it's an addition polymer, and therefore it's formed from an alkene by addition polymerization. So that means that if this is what your alkene looks like, with 4 groups on the corner, so let's call them X, Y, Z, Q, the repeat unit of the polymer that comes from that just again has those 2 carbons, the double bonded ones only, across the middle, and then on the 4 corners you get X, Y, Z and Q. And if you have more than one repeat unit, they just join together, same thing repeated again, so X, Y, Z and Q, like that, and so on. So in this particular question, the first thing it asks is what class it belongs to, so as we said, that's an addition polymer. And the monomer is just formed from those 2 carbons plus whatever is attached to them. You might find it helpful just to draw a bracket round it so that you can convince yourself that that's now repeated in the next one, and that means that the monomer is this. So the same 4 things on the corners as you had in the repeat unit of the polymer. Okay, so now when it comes to writing a balanced equation, we have to use n to represent the big number. So we write out our alkene again, which was this. So n lots of that, polymerized together to give you the repeat unit, n times. So you draw out your repeat unit, and this time you have to put it in a bracket so that you can show that you've got n copies of it. And you must make sure the linker bonds at the end stick out through the brackets. And then you put a little n down there to mean there's n lots of that. So that's your balanced equation. So now in question 2, it wants us to apply those ideas to some other monomers. So hex-2ene, normally you might write it out as a skeletal formula, and you can do polymers with skeletal formulae, but it's probably easier to stick to the script and just say, right, let's draw it out like this. So hex-2ene, we've got 2 carbons there, so we'll have 4 more. So that's hex-2ene. And so that's now going to have to be turned into a repeat unit and repeated 3 times. So that means we're going to get, you know, they're a bit tedious, these ones, but you just have to do it. So you have the 4 carbons, and then you might need a nice long linker bond there, but it doesn't matter so long as it's all connected up. And the same thing again. And here's the 3rd one. So it's all very formulaic. Oops. Yeah, that's right. You just have to make sure that you copy the repeat unit faithfully each time. And don't forget the linker bonds always on the end are necessary. Okay, so the second one, 3-methyl cyclohexyene. You know, normally you would draw it again as a skeletal formula. So if that's carbon 1, you read through the double bond to 2 and then 3, so that's 3-methyl cyclohexyene. But unless you're confident about these polymers questions, stick to the script and just say, right, I'm going to draw my alkene out in the normal way, like so. And so these 2 carbons are now part of a 6-membered ring. And when we get to, if this is carbon 1, carbon 2, carbon 3 has a methyl group on it. And so you can just draw it out like that. And then it becomes easy to see that the repeat unit works in the normal way. So you get where the double bond was, the chain of carbons. And that's now still part of this 6-membered ring. So we can complete the repeat unit like that, and then just go on and draw the next one in the same way, and so on. So, you know, putting rings in and things like that, these are the ways that they can make these questions a little bit more complicated, but so long as you stick to the script, then it's actually pretty easy. So there's the second one, and the third one is just going to be the same again. And there we are.